long-term contracts. Handling challenges can also be difficult. One of the things we're looking at is if we do 10%, that's 90 megawatts of biomass fuel in our boiler, how do we get 90 megawatts worth of fuel to our facilities? It's a real challenge. It's a lot of biomass. It's hundreds of trucks a day potentially. On the landfill side, this is something that we've been quite successful with. We've had already in place for several years a 10 megawatt landfill gas project at the Orange County landfill. We're getting ready to expand that to 22 megawatts, and I'll go through those projects in a minute. 24 hours a day, that's available to us, and it's extremely low cost. It's cheaper than natural gas for us. So anytime we can pursue a resource like that, we absolutely will, and we are. It does have a lower BTU value than natural gas, and it does often need to be cleaned, so there are some additional costs there to keep from corroding our boilers. And then again, it's location specific. You don't have landfills everywhere, so therefore landfill gas is not available everywhere. On the thermal and electric side for solar, some of the benefits are the fact that you are hedging your pricing. There are no fuel costs. So once it's in place for 30 years. It is carbon free, and it can be distributed near the user. That does take some changes to our infrastructure, but these are changes that we're working toward, and that can be accommodated. Thermal is definitely a low-cost option, and it's something that we are pursuing with vigor. And they do create local jobs because it does require labor to install and maintain these systems. Some of the challenges is until we really figure out some of the key factors for integrating these technologies into our grid via smart grid or other methods, they're not typically dispatchable. They are relatively predictable, but not necessarily dispatchable. So we can't always have it exactly when we need it, and that's a bit of a challenge for us. It's not something that comes with any of the other fuels that we're currently using. And on the PV side, it is still pretty expensive compared with what we're using right now. So without a carbon tax or something to increase the costs of our conventional fuels, it's a little bit difficult for us to justify purchasing large amounts of capacity of solar and raising the rates of our customers accordingly. And then right now, PV, at least, thermal does a little bit on the winter side if you're using your hot water heater, but PV does not have a huge impact to our winter peak. So we still have the challenges of building enough power plants to meet your maximum load, and that's how we design power plants is whatever point along the way of the year is your maximum load, that's what we have to build a power plant to accommodate. So that's a little bit of a challenge. So talking about that, what I've done for you is pulled up 2 of our peak days for the year. This is our summer peak day from last year. This is June 22nd. And you can see how we met our peak day. We used primarily coal. You can see the 3 bars that sort of move, but they're about the same thickness. That's because those coal plants, once you ramp them up, they're running 24 hours a day. So mostly coal with a mix of landfill gas in there. And then at the top, you'll see that we ramp up our natural gas as needed to meet our peak day. And this is, again, in the summer. You can see we're peaking right around 4 p.m. So that is how we're going to design our power plants to meet that peak of around 4 p.m. At the bottom there, we've got a few at our Indian River site that are can be mixed with distillate fuels, liquid fuels, or gas fuels. So what happens if you add renewables into the mix? So what I did was I modeled for you 100 megawatts of PV. Right now we have about 12 megawatts of PV installed on our grid, but just for the purposes of discussion today, I went ahead and modeled what it would look like for 100 megawatts of PV on this particular day with PV's profile, an average profile for a PV system. So if we were to add that, is there a way to go backwards? So here's what it was before. I didn't touch the peak. Everything's going to look the same. It's just that some of it's going to be covered differently. And here's where we are now. So you can see that the offset is mostly going to be on the oil and natural gas side for solar. It's going to come in from the shoulder a little earlier in the day because it's going to peak at like 1 o'clock, 2 o'clock. but it will make a contribution of about 35% of its rated capacity. So that means about 350 of those, about 35 of that 100 megawatts will be available to us at our peak period. So when we do our system planning and our long-term planning, we have to make sure that if we put in 100 megawatts of solar, we have to derate it to 35 megawatts in solar unless we have some kind of storage mechanism, because that's what we'll actually get at that period. So you sort of have to overbuild solar in your planning process. It's doable. You can see that it's made a contribution, a significant contribution to our natural gas, but again, that's about 35% of its rated output. So just something to keep in mind. On the biogas side, we can definitely offset natural gas, and I've pointed to that here. And on the biomass co-firing side, there's three ribbons, if you will, of coal can all be co-fired opportunities for us. So those are the kind of things that we're looking at, and these are the ways that we have to work to incorporate it into our daily ability to provide you with electricity. Again, I've done the same thing for winter. I'll just go over it real quickly. You can see that in the winter we have a little more of a challenge in using solar particularly. Our peak is right around 8 o'clock, and then we have another peak at around 10 o'clock in the evening. So a little bit different, a little challenging for us to utilize renewables. So in the winter, we're probably going to rely more on biomass fuels. And you can see there that the PV contribution is sort of occurring when we need it the least. It still has a contribution, again, and it still has value, but the challenge is that it's really not offsetting our peak directly in the winter, so we would have to make that up, bless you, with some other opportunities. Bless you. So what have we done to date? One of the first things that I want to talk to you about is something that we're working on in a collaborative way. We really believe in community engagement and collaboration at OUC. That's what we're all about. So as a group with the City of Orlando and Orange County, we applied for funding to figure out, well, what does it take to build a solar infrastructure in Orlando? And we received a grant to do that from U.S. Department of Energy, and we're in the midst of developing numerous brainstorming sessions on different topics related to solar, as well as training courses for folks like code officials and people getting into the solar business. We want to educate, we want to learn from the stakeholders in the community and figure out, well, what do we need to change to make solar easier to implement in our community? So we're about halfway through that grant. And some of the things that we've accomplished to date, again, the 1 megawatt project was mentioned already, so we're excited about that one. We have a Solar on Schools program. Again, we're working with FSEC on that. And one of the bigger projects on my desk right now is this 10 megawatt PV project. It'll be built on OUC site, and we'll have a power purchase agreement because that makes the most sense for OUC, is not to own it, but to let the investors get the benefits. And we'll have that system built hopefully by the end of 2010. And if you look at our 10 megawatts plus some of the other stuff that we've got with solar on a per capita basis and compare us with FPL and what they're building, we're tied. So I feel pretty good about that as a little mini muni. We have selected our vendor, and that will be announced on March 9th. So we're very excited to move forward with this project. We also offer programs for our customers directly. Right now we have over 300 customers signed up for our solar programs. That's solar hot water and PV. And we decided to go with a different track. A lot of people were really pushing feed-in tariffs. We looked at that model, and for our market it didn't make sense. So we went with something that's similar to a feed-in tariff, but it's called a production incentive, and it's on the customer side of the meter. So they get the full demand savings, which you don't get in a feed-in tariff, and they get a payment per kilowatt hour. So we did both. We also offered a loan program because what we heard in focus groups from our customers is that the upfront costs were a challenge for them. So that's how we addressed it. So we offer 3 cents per kilowatt hour equivalent for solar hot water systems. We use a BTU meter to measure that. And we offer 5 cents per kilowatt hour for a PV system. That's on top of net metering. So you get net metering plus 5 cents. And you get 5 cents on everything you produce, whether you're using it at your home or you're feeding it back to OUC. Additionally, there are some costs associated with this program because we have to measure and verify the production of these systems in order to pay you. There are some extra metering costs that have been a challenge for us with this program. So at the moment, we're offering a $250 credit to compensate for that cost of installing the BTU meter. We may be changing this program as the market changes, and we have found that if I roll all my costs into this program, it costs me about 10 cents a kilowatt hour to get this solar, whereas the contract we're negotiating right now for our PV project is about 19 cents. So for me, this is the least cost option to pursue solar in my service territory.